Right. So let's go through some basic questions. Now these are things that you're already familiar with. You have these questions with you. So you might, if you can't see them on my screen, open them up on your screens as I suggested earlier. So we have 6 questions. The sixth one is 6 questions for the first hour. The sixth one is optional, but let's try to do that also because that's quite interesting. So this is asking review questions. What is a syntax error in a Java program? So I'm going to write my answers in Notepad. All right, so let's go through this very quickly. We have 15 to go through and approximately 10 minutes for that entire question. So 2 questions or more a minute, which we can't do. But anyway, what is a syntax error in Java? What's a syntax error in general? Yep. What is a syntax error? Like a spelling mistake or a typo. All right. Now, there is one strong giveaway of a syntax error, and you should include that in this answer. And that is, it's a spelling mistake or a typo that can or that will be detected by Java or the programming environment. So that's the main thing that differentiates a syntax error from other types of errors. So if you're scratching your head over, okay, is this a syntax error or is this some kind of other type of error? If it underlines it in red under Eclipse, it's very likely a syntax error. Okay, and if it says I can't run this program, especially if it says it can't go ahead and run the program, that means it's a syntax error. What is a logical error then? Sorry? Wrong output? Yep. So the program is valid as per the language it's written in, but the results aren't as expected. So an error by the programmer. So that's a logical error. The compiler or the environment that you're using, like Eclipse, can't tell you this is wrong. For example, if you're supposed to add 2 numbers but you multiplied them instead, that's a logical error. As far as the language is concerned, you have written it right. There's nothing invalid or illegal about what you have written as far as the language's rules go, the rules of the language goes, but that's the problem with the programmer. Question 3 is asking, how is a syntax error detected? Yeah, so the compiler or the programming environment detects syntax errors. And how do they do it? How would you do it? Or how would Microsoft Word or any other word processor do it if you type something wrong? Yeah. Sorry? Read line? A red line, yep. That's how it shows it, but how does it detect it? How would you do it? If you were to, okay, so someone writes an essay and gives it to you and you see a lot of typos and stuff, right? And how do you do that? How do you figure the individual typos out? Well, you look at something and you compare it against what you know about the language, right? So that's the same thing that goes on here. The compiler takes what's written and compares against the words of the language, that is Java in this case. And is that it? Now here's another situation. let's say you're writing a nice technical report using a word processor, and you have invented some new terms, right? Like abbreviations or new terms. You're creating a software system, and so let's call it ABCD, right? Now you're saying this new ABCD is really good, and then the word processor will say, okay, ABCD is not a known word, that you spelled it wrong. But it's not. It's what you want to say. You have explained it before. So what would you do in Word if that sort of thing happened? You would add it to the dictionary, right? And then it will ignore that word. Now this sort of thing also happens with your smartphones when you're typing all kinds of stuff in your texting, and it remembers, and it even suggests if it even suggests for you whether you want to say what you have said before. So it's not always stuff that's in the core language. It's also stuff that you have defined, or that have been defined. So the compiler takes what's written and compares against the words of the language, and words that have been defined by programmers, and identifies what's not valid. So that's how it does it. And moving on to question 4, how is a logical error detected? Sorry?
We have to check it by ourselves.
Yeah, and someone else was saying? Sorry? Test it? Yeah. So, compare the produced results against the expected results, and manually read through the code. Some people call it do a dry run. I haven't heard people say that too much lately, but that's another term that's used for just checking it out on paper or on the screen manually. Right? Question 5. What is an identifier in a Java program? I actually mentioned this. Yeah, sorry?
They are the name of variables that it is in classes, but not objects.
Yeah, remember how in for the answer of question 3 we said words of the language and words that have been defined by programmers? This part, what I have highlighted. So those are the things we call identifiers. All right. So identifiers are names given to identify things that the programmers have defined. Example, variables, methods, or variable names, I would say, or method names. Those are stuff that you have come up with if you wrote the code, and those are identifiers. When you say model dot, you are referring to a word called model that you have actually come up with. So that's an identifier. You use it to identify something. Question 6. Name at least 3 keywords of Java that you have already used. Now think about the bare minimum Java program that you can write. That doesn't do anything. You will have public class and name of the class. So class name, right? And then you'll have public static void main string args, like that, and that's your bare minimum Java program. Of course, this thing can be anything, right? Some class name, right? Okay, just to emphasize that it can be anything. Now keywords. Now keywords are sort of like the opposite of the words that you have defined. or they are the words that are a part of the core language. Yeah, so let's start from the first keywords. Public, is it a keyword? It's a part of the language. Yes, class, it is also a special thing. We won't create a public class called class. We don't do that, and that's because class has special meaning to it. We won't create public class public. So public and class are keywords. Static is a keyword. Void is also a keyword. And let's stop it at that, because if we go much further, then we are getting into a bit of a can of worms situation. So let's we have 4 when we needed only 3. So these are some of the bare minimum things you need to have. So they are a good bet as an answer to that sort of a question. Question 7 is asking, what are the rules governing what a valid identifier can contain? $sign. If there is one main rule that we can say about things like variable names and method names, it must start with an alpha character or an underscore. You don't really want to go beyond that. You can have numbers in the middle, and you can have you can have numbers in the middle. That's not an issue, as you'll see in question 8. But you don't want to have things like strange characters and all that. All right. So the main mistake that people make with an identifier is starting it with a number or something. And that's what question 8 is about. Which of these identifiers are valid? Which is valid, which are valid? We have $cash, third mark, and mark 3. Is the first one valid? Well, if there's any doubt, we can always test. And in programming, it's always easy to test something out. So I'm creating a new project. Finish. New class. I'm not creating a package name just because it's not necessary. Let's call it variable name test. Give it a sensible name. Click that and finish. And there's that bare minimum Java code. Soon, there it is. You don't need this line. We can just get rid of that line. Which, yeah, there you go. You don't need that line. And let's create a variable. So int $cash. Yep. So int $cash, and we'll put a value there 7. Now immediately we got something red. Well, it's not used. That's okay. So it's not an error. And system.out. Oops. It always takes a lot of time looking up what I want to write when I know exactly what I want to write. Anyway, and it does this. So out.println, again it's trying to see what I want to do. Yeah, now let's see whether it works. Alright, so what do you get? Is it running? Yeah, it works fine. So, but I can guarantee that you should not write that, although it's valid. Okay, because it's extremely, I can't remember seeing any variable defined like that in a normal program. So it's not in coding convention. The other one is third mark, right? So int third mark. Let's put another value, and we'll see whether it works. Third mark, and run it, and see it's saying can't go ahead, there are errors. So basically saying token 3, delete this token. That's a fancy way of saying get rid of it, right? So then you're fine, because then it starts with an alpha character. But yeah, so that's the issue. Or you can put a underscore in front, and then it'll solve the problem. Now sometimes in some, again, also rare cases, you see identify name starting with an underscore. So that's acceptable in some cases, but yeah, you don't want to start with the number, and also the dollar thing we don't want to do. And of course, we know the third one, which is Mark 3, is fine. Seven, eight, nine. All right. So okay. So dollar cash is valid, but avoid using dollar in in identifier names. You don't want to say dollar amount to store a dollar amount. We don't do that. Please keep that in mind. And third mark is invalid since it starts with a number, and mark 3 is valid because it doesn't have any problem. All right, question 9. What is a string literal? You have seen strings. Let's create a string also. Yep.
Set of characters.
Yep. So when you create a string, that's a string variable. It's not always, this part is not really what a string must be. You don't need to have that. Even if you say system.out.println and then put that inside, this is still a string. You don't need to store it in a string. So it's one of the common misconceptions. You have to store it in a string for it to be a string. No, it's always a string if you put it inside double quotations. So a string goes inside double quotations, open and close, or goes inside. The other thing is, whatever you put inside will not be evaluated, as in Eclipse or the compiler will not try to make sense of it. It'll just put it out literally, and that's why we call it a string literal. It just doesn't care what's written inside it. So even if you look at this code that we wrote, we had hello world, and now if we say inside quotation marks, if we say mark 3, which we know is the name of a variable, what's going to be printed? It's just going to print mark 3 straight up. It's going to take it literally. All right. So if you want a value to be evaluated, you need to put it without the quotation marks, which is what we do most of the time. So that's going to be fairly useful in some of the exercises for this week. And question 10 is asking, why do we use a variable? What happens when we assign values several times to the same variable, such as when we say x equals 4, x equals 7, x equals 3, one after another. So let's start with the answer to the first part. Why do we use a variable? To temporarily store values, right? And someone might ask, okay, so where are they stored? Is it on your hard drive? Is it on your pen drive? Is it on your Google Drive? Where are they stored? In the RAM. In the random access memory or your computer's primary memory. And so then they might ask, okay, what do you mean temporarily? Is it like 5 seconds, 1 minute, 10 minutes until you turn the machine off? What does temporarily mean? Or is it 5 years? What? Sorry? Or sometimes, sorry? Until the code stops running? Yeah, okay, so we'll go with that. To temporarily store values in the RAM while the code is running. And someone, again, another really annoying person comes along and asks, so what do you mean by code? Is it like if I create a variable inside a method, do you mean it's going to be there as long as the program's running? What are you going to say to that? Yeah, so temporarily store values in the RAM while the method in which the variable was declared is running. Let's read that again to see whether it makes sense. To temporarily store values in the RAM while the method in which the variable was declared is running. While the method is running. Okay, so what about when you have a variable in a class defined at the class level? You probably haven't seen that at this stage, but somewhere down the line you're going to look back at this answer and think, oh, hang on, the only time we defined a variable was not just inside methods. We defined them inside classes as well. Then what happens then? So how can we incorporate that into this answer? So to temporarily store values in the RAM while there is an instance of the code block in which the variable was declared is running. Now suddenly a very simple answer became pretty complicated. And I'm not saying that this is the best wording that we can come up with, but what's more important is your understanding of this. Alright? So you have to understand two things. Sometimes questions look really easy, but to give a good answer, you need to really think about it. You have to cover your tracks. You don't want to let anyone else sort of pull apart your answer and find you at fault. So we all know a variable is a temporary storage space, right? And we like to leave it at that. That's how most people would describe what a variable is. But you really need to explain a lot of things, even if it's a little thing. Otherwise, you're going to your answer is not going to be strong enough. And that's one thing. The other thing is so I lost it. I forgot what I was going to say, but yeah. So I'll let you know when I remember it. All right. Yeah. So we have a second part of this question. So what happens if you save stuff to the same variable over and over again? Yeah. If you have code in between, that's a good way of saying it. Yeah. 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 So if there's code in between, okay, so the value that x will evaluate into will always be to the value that was assigned to it last, right? So let's put it that way. Whether you have code in the middle or right at the end, whatever the last value that was assigned to x, that's the value it's going to contain. All right. What is the role of a method, a class, and a package in Java? Let's add one more to this. What's the role of a project in Java? Let's start with that. What's a project? So where did we see projects? When you say new, Java project, right? And have we seen the word project anywhere in our code? No. So our Java code is really this thing, this part that we have highlighted. And there's no such word as project anywhere. When we had package, when we added a package, it was up here. Package, main, or whatever, right? We had that earlier. Now I didn't add it to this one because I said it's not always necessary. But so where does a project come in? What's the connection? I want to make that very clear because you come across that word project a lot as well. So a project has nothing to do with Java. It's something to do with the way Eclipse works. So it's like creating a blank canvas. So project is like a blank canvas or a canvas in Eclipse. It has nothing to do with the Java language itself. If you're going to write any other type of program also, you'd still need to create a project under Eclipse. It's an Eclipse thing, so don't confuse that a lot with things like method, class, and package. So what's a method then? A method, I have explained that a method is like a button on a control panel. You press it and it does something. We had, you have seen methods like model.up. It's a button, you press the up button and it'll move the model up. That sort of thing. So a method is what? An action performed by an object. A method contains a sequence of instructions and what else? If you're going to tell someone to turn up to some place, do you just tell them, oh, by the way, turn up? No, you have to tell them where and when, right? So you need to give it data. So a method contains a sequence of instructions and data. So the main method that you have seen that we write, hang on, that's my Eclipse. Yeah, so the main method is a method. It's an action, it does something, and in the future you will see lots of other methods as well. All right, so I'd like to hear from everyone as well. So what's a class? Yep, and yep, so holds methods and data. You will also see that you can have class level variables. So we call them properties or object properties. in general terms, global variables in some ways. So holds methods and data for what? Of a class, right? Holds method and data of a class. Now let's expand that a bit. All right, so methods will contain variables inside and instructions, and the class itself will have its own data. So, and earlier we said that a variable lasts only during the lifetime of the code block in which it's defined. And what can we do with a class? If I want to create a few cars, let's say, do I create separate classes saying car 1, car 2, car 3, like that? Now think about a certain car manufacturer, and they're coming up with a new model, right? Do they create a way to create each and every car? No, they have one blueprint, right? And using that, they will create multiple instances. Now some of those cars will have slightly different properties, right? Some of them will have bigger engines and different colored paint and all that. So those are properties. Those properties belong to that object. They are unique. So that's this data stuff we talked about. So holds methods and properties of a class. The class can be used as a blueprint to create one or more objects. Example, car class can be used to create objects car 1, car 2, etc. Each car 1, car 2, etc. object will contain slightly different properties, different colored paint, etc. So the color will be red, blue, whatever the colors that are available. Nowadays usually 10 shades of gray or black. It's no reference to that movie, by the way. Anyway, the next one is a package. What's a package? Now, if you want to write code, you need methods. And if you want to have a method, you need to put it in a class. But you don't need to put all your classes inside packages. So a package is an optional way to put several related classes together. We'll say organize several related classes together. You don't always need to have a package, and here's the proof. It's running without a package. It's a good thing to have, but I don't want you all to think that you need to have it. Alright, let's move back to the other stuff. Question 12. What are the main control structures and how do they differ? Now you'd have seen these being mentioned, and we have covered some of these things. We said a method contains a sequence of instructions and data. Okay, sequence is one of them. How do they differ? Sequence of instructions performed one after another. Well, that's really what sequence means. Now, what are the other ones? There's three, right? So there's sequence, and you would have heard of selection. Now, these are jargon terms actually. So selection is a fancy way of saying you don't always do things one after another. So it's a little bit different to sequence. You are saying that I'm doing things selectively. And how does a computer do things selectively? Not because of the way it feels. Computers are pretty logical. They will have to perform certain checks, and if it thinks, okay, this is the correct answer to this, it'll do a certain sequence that we tell it to do. So selection is performing a check. So evaluating a condition and then executing a sequence of instructions. In very simple terms, it's like saying if the road ahead, or if there's nothing immediately ahead of you, you can move forward by 1 meter. So let's give some examples. I think that'll help things. Person dot, or we can say, we'll say person dot move forward, or take a step, move forward, right? That's a sequence. You might have a few of those. Move forward, move forward, move forward. Selection is saying if nothing in front, person dot move forward. Now, I'm mixing Java and plain English. I just want to give you an idea about what this is about. All right, so the idea is you check, you perform a condition. If nothing in front, then you move forward, and that's it. All right. So, and the final one is called repetition. Now, by repetition, we normally mean, or we'll often refer to a specific type of repetition called iteration. So repetition is very similar to selection, and it's performing a check, evaluating, okay, so performing a check, and then executing a sequence of instructions, and then checking again. So it is repetition. You're repeating it. So if we were to use this example or modify that example, we will say while nothing in front, keep moving forward. So nothing in front, move forward, nothing in front, move forward. So it is a repetitive thing. So that's repetition. There are other types of repetition like recursion, and we're not really going to go into that, at least not yet. So this sort of thing, selection, doing things conditionally, and doing things iteratively, gives us the ability to do very, very complex and useful things with computers. All right, let's move on. In the sequence control structure, does the order in which the statements are carried out, does it matter the order in which you write things? Yes, the order matters. It's called sequence for a reason. What must be done before we start writing a program? If you read the next question, it actually gives the answer away. Create a strategy or a plan. Right? So create it on paper or somewhere else. have a good visualization of the problem that you want to solve and how you're going to solve it, then start writing the code. In reality, this doesn't happen. People just start writing the code. That's okay if you're doing small programs, but when it comes to really large programs, the time you spend on planning actually pays off, uh, because it reduces the amount of time you'll be tearing your hair out debugging and figuring out what's going wrong. So it actually is useful to plan ahead. It's not just people shaking their finger at you and think about what you're going to do. It's actually a really useful thing. So the 15th question is, can there be more than one strategy to solve the same problem? Yes, absolutely. Yes. And does it mean that we can just do things any way we like? For example, if I'm supposed to go to that door, um, that's one way to go. I take the shortest way to get there, right? Now, that doesn't mean that's the only way to get there. I can go to the other room, I can walk around everywhere and still get to the door in the end. So does it mean that there's more than one way to do it? Well, yes, strictly speaking, there is more than one way to do it, but should you be doing every way in any way? No. You have to really think about what the best strategy is. And I want to show a thing called Occam's razor. Now, who has heard of Occam's razor? The Simple English Dictionary, Simple English Wikipedia article. All right. So that's Occam, I think. All right. William of Occam. All right. So it's an idea in philosophy. Who has heard of this? Anyone? No. What it means? Yeah, you have heard of it. Yeah. 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 The best way to explain it is how it applies to programming. Actually, it means that if there are two solutions to a problem, the simplest one is the best one. So, like I said, if I want to go to that door, the shortest path of going there is the simplest solution. Now, if I go everywhere and get to the door eventually, that's not the simplest solution. So that's not really better just because it works in the end, because I waste my time walking around. And if I get extreme and I think, okay, I'm going to check the Euclidean distance from here to the door and walk over the people and on the tables on the way to the door, that's also not a simple solution. It is a shorter solution. Might be a faster solution. It might be quicker for me to get there. The distance is less, but I will have to walk over other people. I'll have to walk over tables, and that's not a simple solution, right? So the answer is yes. There's usually more than one way, but the simplest method that meets the requirements is the best method. So if you're going to do something, plan out, find out whether there are other ways of doing things, and do the one that meets the requirements in the simplest possible way. So you'll hear a lot of people on forums and things saying, oh yeah, it's programming, there's more than one way to do it. And some people will say, oh, my program was not like what the lecturer wanted to do, so they took my marks off. If you look at the details of what has actually happened, it's probably they did a really crazy roundabout thing when they should have done a simple thing. So as far as academics go, we look at why the student did it in a really difficult or roundabout way. Is it because they knew how to do it in a roundabout, difficult way? Or is it because they didn't know it and they got someone else to do it for them? Either way, you don't want to be in that situation. So always plan out and think about the simplest solution. Alright, folks. So let's move on to some of the programming questions. Now this is an interesting one, and it's actually not a difficult one. All you need to do is just get a piece of paper and plan out what needs to be done to move the arm, and you're told that you have these operations: model up and model down for the first arm, and extend and contract for the second arm, lower, raise, pick, and drop for the third arm, which is the part over here. And so you will have some number of, you need to take it from here, pick this up and put it back and bring it back over here. So let's do this really quickly. I need to raise this. To clear this thing, how many times do I need to how many times do I need to say up? 2 times, right? So I will say model dot up 2 times. So this will be tall enough to clear it. Then I need to move it across 1, 2, 3, and 4 times. So model dot extend 4 times. Yep. And then it'll be over here. Then I need to lower it 5 times. The third arm has to be lowered 5 times. 5. Okay. Then I can pick up the red box. Now comes the annoying part. How far do I need to raise it? This is where you really need like a grid or something. So this distance was 5. So if you raise it by 1, 2, 3, 4, 5, I think let's see, 1, 2, 3, 4, 5. Yeah. So you'll be at the same height as this thing. So you need to raise it by, you need to raise it 5 times. Just the same way we lowered it 5 times. So model dot raise 5 times. And then you need to actually lift the main arm up one more time to clear it, because now you're holding it. Yep, so it'll be up here, then it'll finally move up here. Then you can model dot contract. So 1, 2, twice, and that should be enough. Then you say model dot drop. Let me know if I made a mistake here, right? So model dot drop, and then you can't just leave it at that. It says the robot should return to the original position at the end. So a requirement is a requirement, and we are very particular about people meeting requirements in programming. So if it's written saying that you have to bring it back, you need to bring it back. Otherwise, you would actually lose marks because some of the instructions would be missing, right? So that'll be up here. So we need to contract 1, 2, again twice, and then we'll be up here, and I need to bring it 1, 2, 3. I need to say model dot down 3 times. So manually verify it and let me know if I missed something, but it's a fairly fun exercise. It's not, you can always test it out and through trial and error and figure it out. And it's not, yeah, it's an artificial problem. Moving on from artificial problems to something a little bit more fundamental and abstract and applicable to other stuff. Question 3 is asking, what will be the output of the 3 println statements? what do we have? So it's telling us that the math.max will return the larger of the two, while math.min will return smaller of the two. So it only takes two things at a time, and that's something to keep in mind, because this is coming up in the lab questions also. And it only compares two things at a time. So if you want to compare three things at a time, you need to compare two at a time, and then compare it with the last one. So this is just like a tournament selection, like when you have some World Cup sort of thing. The only two teams can play at a time, right? So a pair of teams play, and then the winner of that plays with whoever's remaining. So same story here. So let's put some values into this. We'll put 3, 5, and 7. So from this one, we will get the maximum of x and y. That would be 5. So 5 would be assigned to A. So it will be like A equals 5, right? And in this one, the maximum between A, which is 5, and Z. So Z is 7. So B is equals to 7. So this will print 5. This will print 7. And whoops. And what's going on here? Now we are using the min. So we are saying math.min, and the way Java will look at it is like this. It will put some comments and show how the evaluation will take place. So you know how min works. It will take the minimum out of the two given, right? So y and z, y is the minimum, the smaller one. So this what I have highlighted right now will be replaced with 5, like that. And then it will compare x against 5. So I'm just trying to show the steps of what's going on. So 5 is what? No, x is 3. So 3 and 5. So the answer of that will be 3. So that's what this is going to print. So that's how it's going to evaluate things. Now, if you had an arbitrary number of values that you had to compare, you can't use this min approach. It's not nice. There are nicer ways of doing things, and yeah. So let's take a look at question 4. What will be the output of the program below? We have x equals 10. So value of 10 is assigned to x. So x is going to be 10. And as I said earlier, do it like this. Copy the code, for example. And we had x equals 10. Right. So there we go. And replace things. So x equals x times 2. That means it's going to look at this side first and evaluate that out, right? Expand that out. So it'll say, referring to x. So x is 10 the last time it checked. So this side will be calculated. 10 times 2 is 20. So x is 20 now. That's what will be assigned in the end. And here 20 gets put there, and 20 times 2, 40 is going to be assigned to x, and that will be 40, and 40 times 2, 80 will be assigned. So this will print x is 80. And what do we have here? We have 2 times 2, 4 gets assigned, right? And 4 times 4, 16 gets assigned, and 16 times 16, what is that? 256. It's alright if you can't do it in your head. That's why we are using computers. Yep. So this part, as we said, if you put something inside quotation marks, it's going to be taken literally. It's a string literal. So just because we put it, just because we say x there, it's not going to be evaluated or expanded. So that's just going to be printed just the way it is. Yeah, so when we say plus x, it's just going to join up or concatenate the value or the evaluation of x to that text component of that print statement. Yeah, so it's just going to say x equals, because we said so, it's going to take it literally. And then when this plus over here is to say, okay, join it up. So strictly speaking, this is going to be printed like this with the spaces. Yeah. And in this case, it will be y equals 256, because that was the last value of y. Let's move on to question 5. What will be the output of the program below? Essentially what we're doing is, now I want to show this because it's useful for other stuff also. I'm going to get rid of this. Alright, so So 10 goes into x, 20 goes into y. That's how they were initially. But when you say you want to override the value of x with the value of y, x gets assigned the value of y, right? So which is 20. Now at this point, like what we did earlier, step by step when we look at it, this is basically saying y equals whatever x is. Now x has the value of y, so this is also going to be 20. Yeah, so it's not going to show anything different. It's going to show 20 and 20. The reason why I typed that up is because of the next question, which is an advanced one of this. So I'll show it to you all as well. So we have the values 10 and 20, and then we also have something called temp. So the temp variable we are told we should use to swap the values, right? So how do we swap the values of x and y? We sort of tried to do that, but we ended up with both ending up with the same value. So how do we do it? What do we do here? Sorry?
10 equals to y.
Yeah, so you can do it either way. You can put one of these values into temp. So because to keep the same order that we had earlier, I'm going to say temp equals x. So the value of x is now kept aside. We keep a record of it separately, and then we put the value of y into x. Now we haven't lost x because we know the value of x, which we stored earlier in temp, right? So we can do this and there's no problem. And now finally, when we want to put the value of x into y, we have to get it from the original value of x, which is in temp. If we run this, it'll be fine. And in situations like this, it's also a good idea to print out your variables. It's one of the simplest debugging skills you can develop. You can say before and after. So this is after, just like in the cosmetic advertisements. You have bad lighting and everything in the before, and good clothes and nice lighting in the after. Alright, so okay, wait, what did I miss? So if there's an error, just keep your mouse over. I copied too many things. Yeah, so that should do it. And oh yeah, see, this is why I don't like fancy editors. I like to use Notepad when I'm writing Java, because I don't need colors. I just need to see the code that I have written, and I don't want it to tell me what to write. Alright, but anyway, here's your before x10, y20, after is 20 and 10. Now this is one way of doing it. So for the answer of this, as the answer you could say the answer to 6 is that. Alternatively, you can do another thing. I'm going to show a way of swapping the two variables without using a temp. I'm going to get rid of temp. I don't want temp. So how am I going to do this? First, I'm going to take x, and to x I'm going to add the value of y. Alright, so let's see what happens. X was 10 before and x is 30 now. Y still remains at 20 because we haven't done anything. And to y, I want to, so I need to put the value of y into x, right? So onto y I will put the value of x, which I will do so by saying x minus y. So x is 30. 30 minus what y already has will give us 10. So y will have 10 after that second operation. So y will actually have the value that we want y to have in the end. And now x is still too big. It's got the two values. So what we need to do is get rid of the value that we don't want from x. So we say x minus y. That way we have swapped the two variables without using a temp. It's a crafty way of doing it if you absolutely have no option but to use only the variables that you have. You don't need to really know this method, but look, there's only pluses and minuses in there. It's not anything beyond the scope of anything that you have done. It's the same stuff, just being used in a clever way. I didn't invent this method, of course. I don't want to take credit like that. There's another alternative, and I'm not going to show that, but that involves using what's called the exclusive OR operator. So you can look into that if you like. And I'm going to stop talking at this stage, and I'm going to let you do some of the lab exercises.